G'day, it's Ron from Elfshot Design. We've got a big one today. We're going to build the room in the room. We're going to look at the framing, the solid door, the electrical, the insulation, the drywall, and right through to paint. We've got a fair bit to get through, so let's jump in. The framing starts from the window end of the room because that way I can measure from one end and keep all the studs on consistent 450 centres. That ensures the drywall joins land on solid timber and the insulation batts friction fit properly without any trimming. The bottom plates sit on a plastic moisture barrier, then on 4mm anti-vibration strips to help reduce structure-borne noise transfer. One thing I'd definitely recommend is pricing around for bulk materials. Local hardware stores have a convenience fee. They're not always competitive when you start buying timber, insulation and drywall in volume. Even paying for truck delivery, I'll still save a decent amount going elsewhere. When fixing the plates down, I ran the Dynabolts through sections of fuel hose and tightened them over 12mm anti-vibration pads with large washers. If you don't isolate the bolts themselves, you've basically wasted the effort of the isolation strips because vibration will just travel straight through the bolts and into your timber framing. Clamps really are better than sliced bread. I use them all the time, using whatever solid surface is available to help hold things straight and level while I'm fixing off. There's nothing in this entire build where the solid material passes from the slab or steel frame through to the inside. So I kept fixing points back to the steel structure to an absolute minimum. I think there's only 3 rigid fixing points in the whole room, and I've used the 12mm rubber pads as vibration damping washers and being careful not to over tighten the screws. I wanted a recessed section in the ceiling where my acoustic ceiling cloud will eventually hang from, partly for aesthetics, and if I'm honest, partly because I just like to challenge myself. This was a perfect opportunity to stray away from boring. It's always fun getting the trusty Japanese pull saw engaged. If you're a maker, I'd almost be willing to bet you've got one of these in your shop somewhere. The doorway will carry a 45kg solid core door. It'll also have stops on all 4 sides so I can seal every crack for soundproofing. The header above the doorway is made by laminating 3 sections together to make my 90mm gap. I made a video once called 10 uses for yellow tongue flooring. I keep finding new ways to use the stuff. I could easily make a 10 more uses video. Heavy doors place a lot of leverage on the hinges over time, which is why the hinges aren't evenly spaced. The top hinge is mounted closer to the top of the door because that's where most of the sagging force occurs, while the lower hinges mainly help spread the weight and keep the door stable. For soundproofing, even a tiny gap around a door can leak a surprising amount of sound. If air can pass through, so can sound. I used a self-adhesive rubber bulb seal around the frame, which compresses slightly when the door closes to create an airtight seal. On the hinge side, the bulb seal actually faces the edge of the door, so the hinges don't interfere with the compression of the seal. Getting that compression right is a balancing act though. The bulb seal only wants to be lightly compressed, just enough to stop air leaks, but not so much that the door becomes difficult to close. I also let the door settle for a couple of weeks before installing the seals.
Well, we'll fast forward a little bit now. I've got through most of the framing, and I've also added some sarking to the studs. Now this serves 2 purposes. It's mostly to stop the wall batts from falling through to the back. I want them staying in line with the drywall. And I've also taped around some of the edges and stapled this sarking into the stud work to try and prevent mice and rodents from coming through. That's one of the things that I really don't like, having rats and mice in my shed. I've blocked in along up here, along my rafters. Again, rodent proofing. So there'll be bats in here in this cavity on top of the drywall, and then I'm going to run another layer of drywall on top of that, and these allow it to be boxed in so we won't get animals going in there and nesting. So the other thing that I've done recently is we've had the electrician in. He's run the cable through the walls. I've got 4 coming down for lights. I've got a circuit for the LED mood lighting, got PowerPoints in place for where my speakers and PC gear is going to go. So we're all set up now to finish the drywall, and we can move on to the next step.
One thing people underestimate with soundproofing is how much sound leaks through tiny openings. A standard PowerPoint cutout is basically a hole straight into your wall cavity. I used acoustic rated PowerPoint back boxes to reduce sound transmission. They've got foam gaskets and enclosed backs to reduce air movement. The electrician normally needs to come twice, once for rough in, then again after the plaster and paint for the final fit off. Locking that second visit into the calendar gives you a nice deadline to get your drywalling done. You don't actually need to pre-cut the holes in the drywall. I always used to do this myself, which is useful in some situations, but in this clean build context, you just need to mark exactly where the edge of your stud is. I mark stud positions clearly on the finished wall with a faint vertical pencil line and nice bright post-it notes so you can see where they all need to go, including height from the floor. The 4-gang switch controls the downlights, the ceiling cloud lighting, the feature LEDs, and the extraction fan, which also has a speed controller. This dial looks like a regular light dimmer, but it's not. Light dimmers are designed for resistive loads like lighting, not electric motors. They control power by chopping up the AC waveform, which works fine for a light bulb, but it can be a problem for HVAC fan motors. If you want speed control, you need to choose a fan with a motor that's designed to be speed controlled. Not all fan motors are suitable for this.
I've hired this panel lift, which makes it easier to put your sheets on. Lay them on like that, and then you just flip it over, wind it up. This will take them right to the ceiling. It means I can get the sheeting done by myself without killing myself.
My local hire place does a weekend deal. We only pay for 24 hours, so I effectively had 2 full days with it, from a Friday through to a Monday. That made a big difference because I wasn't racing the clock. I could start at the window end, install the ceiling panels as I went, and then immediately tuck in the insulation and vermin protection before moving further down the room. If I'd only had a single day with the lift, there wouldn't have been enough time to do that. I would have had to close the ceiling first, and getting insulation up there later would have been painful, tight access, awkward angles, and pretty damn hot.
Well, that's enough screws to get the panel out. Unlock it. Just got to screw off now in the middle there and we're done. So I've got my long sleeve shirt on. I've got my mask ready and my gloves, so I don't have to deal with itchy bats. But there's a few things I need to do first. First of all, because of the way I had to build this frame, there's no timber in the corner here to screw the sheet into. There's one on this side for this wall, but nothing in there. So I'm going to add a few blocking pieces of timber in the corner, so I've got a nice solid corner for both sheets. The other thing I'm going to do is mark on the floor where the studs are. Since I'm going to have carpet squares in this room, I'll easily be able to lift them up later if I want to see where the studs are. Finally, I've got my bats open and ready, so I can get into the job once the glue's on the studs, get the bats in, screw it off, and move on.
For insulation, I use 2 different 90mm products. Wall bats are denser and slightly more rigid, so they friction fit neatly between the studs, and they hold their shape in vertical walls without shifting over time. Ceiling bats are lighter and fluffier, designed to fully fill horizontal cavities and maintain their thickness without compressing or settling under their own weight. So even though both products are 90mm thick, they're optimised for how they're installed in the structure. I decided to go with single layer drywall. Yes, double layers would certainly improve the isolation because mass is one of the major soundproofing principles, but realistically my goal here is reducing wind noise and general outside sound, not a drum kit in the suburbs. So for me, the extra time and cost, plus reduced room width, just wasn't worth it. If I had neighbours close by, I'd definitely run a double wall. All the internal corners are taped, including the square set ceiling joins. External corners, like the cloud recess and the baffle box, use metal beading. The reason for using the metal bead is durability. Plasterboard corners get knocked about, and without the reinforcement, they chip pretty easily. The main thing is not over-fixing them. If you hammer in too many staples or drive them too hard, the bead can deform slightly, so I use just enough staples so it's not jingling around while checking that it's flush with the plasterboard.
I'm not sure if it's just bad luck, but cheap staplers, electric staplers, this is about my fourth over the last few years. They just don't seem to last. Maybe just need to invest in a good one.
In an earlier episode, I showed how I tied the new slab into the existing one by dynabolting the mesh into the existing slab. This left a gap that needed filling, so I mixed up a mortar blend, adding some plasticizer to improve the workability, which will make it easier to feather out the edges. I also added some polypropylene microfibers just to help control shrinkage cracking as some mortar cures. Before placing the mortar, I brushed on a bonding agent over the existing concrete. I like to use Bondcrete, just water it down a bit. This acts as a primer. It improves the adhesion between the old slab and the new material, so it bonds properly instead of separating over time. Once that had cured, I used a floor leveler over the slab to flatten out the low spots. There's a layer of plastic for a moisture barrier, and then on top of that I use 6mm thick cork squares as a decoupling layer. 6mm is about the minimum thickness where you start getting some meaningful vibration reduction. Proper acoustic rubber will definitely perform better, especially with lower frequencies, but the cost difference was pretty significant once you scale it across the whole room. So cork ended up being a practical middle ground. The yellow tongue flooring floats on top with just enough expansion gaps around the perimeter for movement. I had some leftover boxes of hybrid flooring, which I thought would make a nice centre section feature. Also provide a durable surface for my office wheelie chair. Most boxes only contain a handful of different board designs, so while laying it, you shuffle pieces around pretty carefully so identical patterns don't end up sitting right beside each other. Then carpet tiles around the perimeter, partly as a design feature, but also to soften some of the reflections near the walls and provide a nice seal for the skirting boards. I was lucky that both materials were around the same height, so I've got a nice level surface from the flooring to the carpet.
When you're sanding drywall walls, if you can get your hands on one of these, well worth it. This folds up, it's got a big sanding pad on the end, good quality sandpaper, spins around, and you plug your shop vac into the end of it in here, and it sucks all the dust away. That's probably one of the best things about it. But makes it really easy for reaching walls, set up on the ceiling. Fantastic. You just got to be mindful though, if you're going to plug a regular shop vac into it, like this one, the filter will clog up very quickly. Every time I finish a wall, I take the filter outside, knock out all the white dust with a stick, blow it out with air hose. You've got to do that all the time, or these things will clog up and overheat. Just a note on the paint, I turn the lights on, even though they're hanging out of the ceiling. This is 4 litres. I had some left over from another project, that's why I stuck with the small tins, but this project size has taken me about 2.5 of these, so if I'd got a 10 litre tin, it would have been perfect. That's what I've got for the top coat, which looks like this. Far more economical if you can buy it in a 10 or 15 litre bucket. My basic approach to painting is to use a 2-inch brush to point in, do a nice heavy coat in the corners, along the floor edge, around the power points after taking the covers off, top edge, around any lights or fittings, and then the roller. Now this is a good tip I learned many years ago. When you finish your first coat, wrap it up in cling wrap. Then you can handle it and it'll stay moist for many days. So you can just keep using the same roller without having to clean it. Now I do have good quality rollers, but in this case I've decided to use a cheap polyester one because it's doing a pretty good job on these walls. It may not be very environmental, but I'm just going to chuck this out when I'm done, so I don't need to clean my roller at all, because cleaning rollers is not very fun. Well, I'm back in the echo chamber again. I'm pretty happy with the day. I've got my second coat of paint on.
and it's looking pretty good. So I'll let that go nice and dry overnight, then pop the lights back in, then we can start work on the feature wall. Well, I hope you're enjoying the series so far. In the next episode, we're going to look at the feature wall, which is just an LED light strip hidden behind a second skin wall. It sounds complicated, but it's not. Hope to see you there, and catch you later.